Hello, everyone. Welcome to another episode of the Tractable podcast. I'm Kshitij, co-founder and CTO here at Orb. And today I have with me Erik. Erik is the founder and CEO of Modal, which is a serverless platform that makes deploying your code to the cloud, and specifically Modal's cloud, really easy. Modal's known for being simple to get started with and super scalable, even at really large workloads, both on CPUs and GPUs. Companies big and small use Modal, including Ramp, Substack, and Suno. So really excited to dive in with Erik today. Erik, welcome.
Thank you. And yeah, it's great to be here. And by the way, that was a phenomenal pitch. I'm just going to steal that.
Well, glad to hear that. I think I want to dive right into the technical conversation. So I want to talk a lot about Modal. Before we get there, tell me a little bit about your technical background before starting Modal. What sort of problems have you historically been interested in? And then maybe you can kind of pave the path from that to Modal and what you're doing now.
Yeah, so kind of rewinding the clock a little bit. Like I grew up in Sweden. I started coding more than 30 years ago. I did a lot of programming competitions in high school and university. And then when I graduated, I ended up joining this then obscure music streaming company called Spotify as I think employee number like 30 or something like that. This is back in Sweden. And in particular, like I, for whatever reason, was able to convince them to hire me to build a music recommendation system, despite like barely having any experience with that. But I started working on that and spent 7 years at Spotify. I did a little bit of everything, but like in particular, I built a music recommendation system, but I also did a lot of other sort of data, AI, machine learning stuff. Later left, and I was the CTO of a fintech company called Better, which has its own sort of interesting kind of roller coaster story. Left 3 years ago and started Modal early 2021, roughly.
And that's interesting that you worked on the recommendation system at Spotify. What was the kind of primary challenges there? Was it like having to come up with a lot of things from scratch because this technology wasn't super hot at the time? I mean, it sounds like pretty early in those days.
Yeah, I mean, this was like, do you remember like Netflix Price? That was like kind of cool. And so I took a lot of inspiration from that. It's a slightly different problem because they had ratings, like Spotify didn't have ratings. But in many ways, it was quite inspired by that. And a lot of, Spotify had a lot of data. Like we looked at who listens to what. And we don't necessarily know whether they like it or not. But like just the fact that they listen to something is a pretty strong signal. And it turns out like roughly what you can do is like you take all that data and put it in a big matrix and then you factorize that matrix. And a lot of NLP models actually work really well. So it's also, so we started looking at a lot of NLP models because you can think of what they listen to as like a token, essentially.
Yeah.
And it's like a sequence prediction if you incorporate time. So I spent a lot of time like building that. And I don't know. I mean, back then it was like 2008, 2009. Like there was like nothing, there was like Hadoop, like there was like stuff like that. And it wasn't very nice to work with. But yeah, we had to scale it out. And I spent a lot of time building distributed machine learning, large scale methods and built a lot of data pipelines. I ended up open sourcing, I think actually called Luigi to do these because we had very complex data workflows. And then I ended up building a vector database because there was nothing like that. I needed it. And so I ended up building my own vector database called Annoy, which is also open source, but no one uses today. And yeah, I mean, it was like an amazing problem. I think it was crazy in looking back that I was in my 20s and they put so much faith. But I think like early Spotify was very much like a culture like that. Like you would give in very sort of audacious goals. And I spent 2 years like just hacking on it with nothing in production, just pure research. And then 2-3 years in, like we were able to get in production and started building features on top of it.
Yeah, I want to dwell on that a little bit. How do you think the development environment and obviously Modal is now becoming a part of that ecosystem, but if you have let's say new grad or an engineer starting today, starting to learn about the basics of how to, deal with data, how to think about deployments, it's a very, very different experience than having the experience you had with Spotify, right?
Yeah.
Because there's so much of the primitives already built for you or at least available to you. So how do you think about that journey? Is that us stepping in the right direction as an industry or is there some tension there?
I think like some stuff is good. Like I think I'll take that back. Most of it is quite good, but I think in many ways we made it harder. And I think that's the story of like software engineering as a whole, right? Like when I started my career, like cloud didn't exist, right? I mean, AWS launched, I think S3 and EC2 around like 2000, maybe it was like around the same time actually, like 2008 or something like that. We started using it at Spotify at that time, but like very limited. Like most of it was like on-prem. And I don't know, I mean, in a way, because it was like pre-Terraform, like pre-cloud, like all this stuff, it was like conceptually easier. You just like SSH into some like box and just write code, right? And I look back at like early coding in many ways, CGI bin and PHP, like it's sort of an easier model. With the cloud and many other things, like we obviously added so many different abstractions, and in many ways we actually made it harder to do things, but also like easier in certain things. So I think conceptually it was easier to get started when I started, because there was like less sort of mental overhead, but obviously the ability to like use all these tools and to deliver value at scale, it makes it so much easier today to actually scale up, and you don't have to worry about distributed data or building your own scaling layer and all these things that back then, like Spotify had to invest an insane amount of time. Just one thing to think about that I think about a lot is Spotify built its own peer-to-peer system for distributing music data, which is today like a problem that's like trivially solved by CDNs, because the cost of CDNs has dropped by probably 2-3 orders of magnitude. But yeah, so things are easier today in many ways, but it's also harder. And part of that is I wanted to build a tool kind of selfishly that I always wanted to have that makes it easy to work with the cloud again, and conceptually removes a lot of the sort of dissonance of I have a local environment, I have a cloud environment, like how do I make it work? And so a lot of that actually inspired how I built Modal.
Yeah. So that's a perfect segue for me. So let's talk about Modal. I go to modal.com. I see cloud functions reimagined. What does that actually mean? So tell me a little bit about the product thesis and the context in which you're working. So obviously I think about serverless functions. Lots of people think about Lambda. Where does Modal fit in, and what does it mean to reimagine a cloud function? Right.
Yeah, we actually ended up changing that headline just like a couple of days ago. I forget what you said, but like kind of taking a step back, like what I wanted to create first was this ability to basically use this fantastic technology called the cloud, but while maintaining these like fast feedback loops. And when I think about like my own career as a developer, and started in '99 or something like that. Yeah, I think that feedback loop to me is like always the best way to look at what makes me feel productive. Do I have fast feedback loops? And that was always like my challenge working with cloud and like working with data. And I would say to some extent, you look at like front engineers, they kind of figure it out. Like you look at backend engineers, they kind of figure it out. But then you look at like data, machine learning, AI, and I just felt like there's no like good infrastructure solution for like how these teams want to work with compute abstraction. So I started thinking about, okay, how do I build that abstraction? Like, how do I build something that like basically makes it super easy to take code locally and execute in the cloud, scale things out, deploy things to as maybe you have an inference model and you want to deploy it and you want it to be auto-scaled. Maybe you have some very bursty, like one-off, you just want to process some video file, but now you want to scale it out to 100,000 video files or something like that. And there's a lot of those things that has been historically quite hard to do. And so what I realized was a lot of that comes back to like bad feedback loop. Like you get something working locally, but now you have to write a YAML, you have to write a Docker file, you have to get things working in Kubernetes, et cetera. That completely ruins that fast feedback loop. And so what I wanted to have was something that lets me execute things in the cloud, but basically it retains the same developer experience, or almost the same as if I'm running things locally, which actually turns out to be quite a hard technical problem. Like because you need to take code, you need to containerize it, and you need to execute it in the cloud, ideally in a couple of seconds or less to have that sort of fast, sort of fluent feedback loop. And so we ended up having to go pretty deep in infrastructure land and spend time on like, how do we start containers very quickly? Realized in order to do that, you have to solve like container image distributions. We ended up building a file system to serve container data. And we ended up realizing like Kubernetes is just not fast enough. So we built our own scheduler but it was totally worth it, because now I feel like we have this system that lets you iterate super quickly. And then actually this like serverless thing ended up being a little bit of serendipitous discovery. Like we first built a system that focused more on like the developer feedback loop and like more like a research type setting. But what we realized is also this is like a year and a half in, like mid 2022, a lot of people started dabbling with Gen AI and Stable Diffusion. And a bunch of those customers came to us and like, wait a minute, could we use Modal for this? And I was actually like serverless inference makes a lot of sense for us, because we had GPU support, we had the ability to start containers very quickly. So we started focusing more on like serverless in like a more of a production setting, more like an online setting. And it turns out to be a lot of the infrastructure we had built lent itself quite well to that ability to iterate quickly to serve online traffic quite well, because we had the ability to start containers very quickly, and we had GPU support and auto scaling and all those things you want.
Yeah, and I guess the way that I would think about that thesis, just reflecting that back at you, is this idea of you can write a bunch of code locally, you can run a function in the command line. You shouldn't have to take on a bunch of mental overhead to figure out how you're going to run it in production. And like all
Yeah.
the kind of DevOps associated with that should ideally be as simple as possible. When does that abstraction, if at all, become leaky? I think I already see instances of this where it's great. I'll deploy my code to a serverless function, but I don't think about the fact that my RDS instance can't handle an unlimited number of connections, right? And so then the database instance falls over, where maybe there's some cases where you do want the engineer to think about the difference between their local environment and their production environment. At what point are
Yep.
you like over abstracting that, and how do you think about the sort of use cases Modal solves at the relation with those?
Yeah, I think that's an incredibly hard problem because on one hand, in order to simplify things, you need to make assumptions. But then
Yeah.
when you do that or add abstractions, either they become like leaky or they become limited or something like
Yeah.
that. Like that. And I think that's been the sort of problem that I look at a lot of alternatives to Modal. And
Mm.
arguably like one of our competitors is basically just like homegrown Kubernetes wrappers, right? Like most
Mm-hmm. Mm-hmm.
companies at a certain size that do a significant amount of like data, AI, machine learning workload have built
Mm-hmm.
some sort of abstraction over Kubernetes
Right.
to
Right. Right. Right.
assist those teams to deploy things into production. In many cases, like those abstractions are not very good in terms of the ability to iterate quickly. But also to your point, like they end up being leaky.
Yeah.
You have this abstraction, but then like you actually do need to understand like how Docker works. And you do need to understand how
Yeah.
Kubernetes works. And I don't know, I don't have a particular great solution to that, but I do think the fact that we focus specifically on data, AI, machine learning
Mm.
does mean that we can think more about what are we actually trying to accomplish, what are the set of use cases for this, and build for that. And that makes it a lot
Yeah.
easier. So far, I mean, I think we found a set of abstractions that work reasonably well for those people
Yeah.
without being like super limiting. Like you can sort of do quite a lot of stuff in Modal. It's
Yeah.
somewhat flexible and dynamic. And occasionally people run up against like limitations. And then we sit down and kind of rethink, maybe we need to redesign this stuff and rebuild it. But I don't know, it's like any program, like any tool, right? That's like fundamentally
Yeah.
the decision is you start with like 100% of the use cases, and then you say, actually, we only want to support this like 50%.
Right.
And then
Right.
you build an amazing experience to do the 50% really, really nice.
Yeah. Yeah. And it's interesting because I think the words you choose also influence some of the use cases people think you want to serve, right? So we're talking about serverless. I think lots of people think of serverless, at least initially, as just it's going to be like a 20-second function that's doing something lightweight that maybe has variable demand. But I know that a lot of folks are using Modal for significantly more intensive workloads and just longer running workloads.
Yeah.
What one, does that resonate? And two, is that something you've had to reframe to people of, hey, yes, it's quote unquote serverless computing, but it's not just for these really small tasks that take seconds or milliseconds to return.
Yeah, I don't know if we necessarily use the term serverless like that much when we talk to people
Okay.
because our audience is very like data focused. So
Yeah.
for them, like serverless is not necessarily. But I do think your question is really good though, and I've thought a lot about this. Is we've had a decade of Lambda now. I think when I saw Lambda the first time, I'm like, whoa, this is like super cool. Everything should be like a Lambda. But I think first of all, like it's not necessarily. I mean, like, I think Lambda in itself has a lot of like usability challenges. It's quite annoying to
Right.
work with. But I also like wonder if fundamentally like the compute model doesn't actually lend itself well to backend stuff because a typical
Mm-hmm.
backend, like one example for instance I think a lot about is like a typical like backend application is like mostly IO bound. Like you have this
Yeah.
lots of coroutines like just sitting around like waiting for IO. And Lambda is actually not that good for that because it ends up being very expensive to like fire up
Yeah.
a Lambda for
Yeah.
every request because like most of the requests is just sitting around waiting for a database or whatever. One thought I've had is that maybe serverless is a great technology, but people have been focusing on the wrong application, which is people have been focusing on like using serverless for backend use cases.
Mm-hmm.
The other thing is
Mm-hmm.
like backend use cases often have like more predictable traffic.
Right.
So,
right.
so I don't know. My thesis is like basically like maybe serverless, like the real application is data, like data, AI, machine
Yeah.
learning, right? Like compute heavy
Yeah.
stuff, right? And
Yeah.
when we're dealing with compute heavy stuff, like you also need much more than what Lambda can do. And so like you need GPUs, you need long running things, you need things that maybe use, I don't know, like 100 gigabytes of RAM and run for an hour or like whatever.
Right. Right.
So that's sort of like a little bit of a thesis I have,
Yeah.
obviously biased, but
Yeah.
that maybe the real killer app for serverless is not what people think it is, like backend. It's actually data, AI, machine learning.
Yeah. Yeah. It almost feels like the thing that Modal is offering is managed compute, and serverless just happens to be a way people think about it and
Exactly. Yeah.
attach a
Yeah.
lot of preconceived notions to.
Exactly.
Let's actually talk about this, the fact that you all support GPUs, because obviously that's a use case you're leaning into. Was that a decision from the beginning? Like, how did you navigate that? And was that a result of AI interest, or was that something that you kind of had some foresight to say, look, this is an important use case for us to support?
Yeah. I mean, it always felt like a pretty core focus for any platform that deals with data, AI, machine learning. Like you kind of have to do GPU today. What
Right.
we didn't know at that time was that how much demand there would be for GPU
Yeah.
and how much of a problem like people have finding capacity and dealing with. And I think that's also like how I think about like why Modal was so successful specifically with GPUs is that there's a
Mm.
lot more value to be provided
Yeah.
specifically around just getting GPU capacity and dealing with the containerization and the drivers and all
Yeah.
of that stuff.
Yeah.
Because it's kind of annoying to run stuff on GPUs.
Yeah.
And we reduce that burden quite a lot. Like it's significantly easier to get stuff running on a GPU with Modal.
Yeah. And actually, that's a particularly interesting point, even from a go-to-market lens, because you're building core infrastructure, you're running it for other people, you're effectively getting capacity, GPU capacity for other people, but there's real kind of cogs to that. So how do you think about? I know you have a pricing model that is fairly precise. I think Bill's on the second, but how do you think about more broadly capacity planning and thinking through the cloud economics of running Modal?
Totally. And just maybe to explain to the user who's not familiar with the business model, like we run a multi-tenant model, right? And we, similar to Lambda in that sense, like we run user code in our sort of cloud, almost like we're almost like a cloud provider ourselves in a way. And even though we use like existing cloud providers under the hood,
Right.
and then we charge customers based on the time it takes in the CPU usage and the memory usage. And so, yeah, I mean, I think that the benefit is like revenue comes quite natural and it's like sort of an obvious point of monetization, just like kind of thinking from like a commercial angle here.
Yeah.
And I think we benefit from that. I think obviously it is a different model than a pure software company and
Mm-hmm.
margins will never be 95%
70,
plus.
80%. Yeah.
Exactly. It's very different. And so we have significant cogs, but we've been able to get pretty good margins. And I think a lot of that comes from our ability, for instance, to leverage spot capacity to some extent.
Mm-hmm.
Like we've been multi-region very early, and I think that's been very
Mm-hmm.
beneficial in terms of if you pool a lot of capacity from different regions, like you can get a bigger pool. And it turns out like actually the latency associated with moving things around is not that significant for most Gen AI applications. Like
Yeah.
you can send a request in the US over to Europe, run it on a GPU, and then send the result back
Yeah.
to the US without
Yeah.
like meaningful degradation from a user experience point of view. So I think it is more challenging for sure. And I think one thing I, for instance, think about is like this, like what I think was like the WeWork problem of how do you handle these like demand that's very short term and like very ephemeral and very volatile.
Yeah.
And then on our side, like in some cases we have to make reservations, like 1 year or 3 year
Right.
reservations.
Right.
And
Exactly.
doing that well, I think is a very hard problem. But like we spend a lot of time.
Yeah.
Like what just one example is like we on our scheduler side, like our code that goes out and like provisions and
Mm-hmm.
terminates cloud instances, like that's actually running 24/7 a mixed integer programming problem to optimize our cloud spend, keep utilization high, find the lowest cost spot instances, move things around. And I think those are the things you need to do in order to get the margins to a place where you want them to be.
Yeah, that makes a lot of sense. And it sounds like there's a lot of technical investment in that area, and not just kind of thinking about it from a go-to-market lens. One thing I'm curious about, and it's a slight tangent, is there's been a lot of talk about the cloud economics of free tiers. I don't know if you've seen this all over
Yeah.
Twitter, but especially
Yeah.
with some of these database providers. I'm curious if you have a point of view on that. To what extent should you, as a provider, and as you were saying, effectively a cloud reseller, be thinking about the free tier as a growth model? To what extent should you just be focusing on the core business and driving revenue? But what's kind of the mix of that story?
I don't have a general point of view. Like I think it's so hard. It's so idiosyncratic. Like I worked at Spotify for 7 years, and Spotify worked beautifully, right? Like the free tier was like never a moneymaker, but
Right.
it was a necessary condition in order to get growth. And eventually you monetize those users through premium. And I think in a way we have a similar view, and I think everyone who has a freemium model has a similar view. Is you almost have to think about the free users as a CAC, customer acquisition cost, right? And then you have to recoup that later because they upgrade. And I think what you're referring to is like Planet Scale got rid of the free tier recently, right? And I understand that it's hard, and I think especially for databases because you end up getting a lot of hobby users. And I think something that's like also specific to databases is the cogs of running databases, unless you have a truly serverless model, it's actually kind of expensive to run a database 24/7 unless you can scale down to zero, which is like why I think Neon, for instance, is like still doing a free model. And I think for them, it's like totally fine to do it because they've reduced cost. I think if you're doing like databases, like you almost have to do serverless, right?
Yeah.
I think for us, it's been a little bit different. What we see is that obviously we have the serverless advantage, but I think more importantly, what we see is, like customers come in and they spend $30 a month and we front that. Like that, you get a $30 free credit every month when you use Modal. But such a high proportion of those users end up converting into high enough spenders that we can recoup those credits pretty quickly. So it's more of a conversion. What's like the LTV? If you're spending $30 a month, you need to get like some of those users to in a few months, like they need to start spending $100 a month, $1,000 a month, $10,000 a month. But they do with Modal. So that's the reason why we can fundamentally subsidize that tier.
Yeah, and I think that's an interesting framing. One thing I've heard is even from just a business discipline and accounting perspective, lots of people will take that $30 a month or free trial credits and put that under sales and marketing spend, right? It's not COGS, it's sales and marketing. And I think what that incentivizes is to take a close look at the conversion rate, the churn rate, the growth rate of those customers, because now someone is on the hook for that translating into revenue in the future, right?
Yeah. Exactly. We don't do that yet, but like we do look at like gross revenue and net revenue, like net of credits, and we have okay margins like in both cases. So like we can, at least for now, I think I want to keep supporting it forever because I'm a big fan of like freemium in general, like being biased as Spotify or someone. But I think for us, like it makes sense. Like these people convert eventually and they convert in a high enough proportion that we can recoup that.
Awesome. Okay, so maybe let's talk about developer productivity because that's a big part of what Modal does as a product, but it's also the context in which I hear a lot about Modal just on social media. People really are champions of the developer experience. I think it's an interesting question of, is there a silver bullet there? Is there something you found to work really well? Is this just like months and months or years of just being really aware that that's the kind of one of the primary value props early on? I want to hear a little bit more about that from you.
I mentioned some of it, which is that I think one of the best ways to think about developer productivity is like understanding it from the point of view of feedback loops. Like how fast do you get feedback? When traditionally you write code, like you have maybe the editor even like these days can flag things like as you're typing, but then you have separately, you have maybe the interpreter or the compiler flagging things. And then you have unit tests in order to, and it's sort of like people refer to this as like shift left, right? Like you want to take these like complex feedback loops and find problems as early as possible. The cost of finding a problem in production and fixing it is like 100x higher than if you're finding it while you're writing code, right? Because then you can just fix it. And so that to me is like the number one way to look at developer productivity. But I think there's so many other different aspects of it too. I think a lot about building tools and developing tools for humans is also like something I think is like it's hard. It's hard enough to write code for computers, but when you're actually writing code for like humans, like that ends up being a much harder problem. You're not just like dealing with a compiler's understanding of the code. Like now you have to think about a human's understanding of the code. And so like when I think about what I want the Modal SDK to look like, I have to try to visualize in my head, here there's a user looking at this the first time. What are they going to see? What are their like mental concepts going to be? And so I think that's like another sort of guiding principle that I think a lot about. It's like, how do we build an SDK that sort of latches onto people's existing mental models of things and kind of just feels like intuitive, and it feels people get this like big, beautiful pile of Lego blocks and they can just put them together and
Yeah.
build something the first time they
Yeah.
try it out. Like that's a sort of,
Yeah.
to me, that's like the magic tools that I've seen. I don't know. Like I think tools like React, I think is just like well designed, and it has this like kind of couple of core foundational building blocks. And then, but then you can snap them together and build like almost anything, and it kind of just works. Torch is another example. I think it's done phenomenal work. It's like a lot of complexity around Torch and all the tracing and eager mode and all of that stuff, but it works, and I don't have to wrap my head around it the same way I felt like with TensorFlow when I tried. Like there are these like well-designed frameworks that I think have done like they really like, what's the word I'm looking for? They really show how to do this well.
Yeah. This idea of the code being consumed for human thought and the human mental model, I don't know if you're familiar, it feels very like Brett Victor-esque to me, like this idea that you have to think about the human behind the screen. I think one of the things that is, to me, seems like a big challenge is designing an SDK that, or just a developer experience more broadly, that is a good fit for the user that is just getting started on day one, and also a good fit for the user that is really trying to dig deep and assemble their own complexity from the primitives. But I think, like you're saying, that kind of comes from the complexity unfolding as you need it, rather than it being presented to you all up front, right?
Yeah. And I think that this is like idea I've heard of, like progressive revelation of the complexity, or whatever people talk about, right? Like that idea that you don't have to understand everything when you get started. I think it's a kind of a beautiful concept.
Sweet. So maybe let's go back a little bit to talking about some of the technical challenges. One of the things you mentioned in this conversation is, and it's part of this kind of really fast feedback loop, is this idea that you've invested into building your own container system. And I think that's brought you a lot of performance wins. And yeah, I think that seems like a pretty big investment, especially for a scaling team and a scaling company. How did that go? I'm curious for the technical journey there.
Yeah, I mean, when I started hacking on this, just myself, pretty quickly, I ran up against these challenges with Docker and with Kubernetes and things like that. And, you know, I had conversations with VCs at that point, more to get to know people. And I feel like the consistent feedback I got from people are like, why would you build your own file system? You're nuts, right? Like people are like nervous about it. But I was pretty convinced that I think this can be done. And I think it's possible to build a proof of concept that's actually not as big as like people think. And I think fundamentally, like to me, the question is also, if you're an infrastructure company, like to some extent, you can't just be a wrapper, right? Like then what's your competitive advantage? If you choose that route, if you want to be an infrastructure company, you have to be very willing to go down and like the guts of infrastructure and kind of rethink a lot of very foundational stuff. And I personally love that stuff. So for me, it comes very naturally. I've encountered like a shocking degree of infrastructure founders or like infrastructure companies who like don't want to do that. And to me, that's like, well, I don't even understand, like, why are you building an infrastructure company then? Like, to me, the fun part is, I mean, obviously there's many fun parts, but I love infrastructure and I love building stuff. And I always respect people who build databases. Like database companies to me is like the most like crazy thing you can build. Cause like you have to spend 3 years in a cave building a database until it's even useful, right? Like Modal had a little bit of an easier route. Like we could make it like kind of useful, like just a year in, but I don't know. I like it personally, but I think for some people it's a little scary.
Yeah, and I know specifically for this container problem, I think Cloudflare has talked a lot about this as well, but that security in SAN is really tricky, or at least it can be. Has that been true for you? And or are there trade-offs you had to take to make sure that like you're focusing on that part of the problem too, which I imagine, especially for larger customers, is of course just like a really big point of evaluation.
Yeah. We don't use, so Docker has a lower level primitive called runc, which was initially what we used. And think about what containers are in like sort of traditional sort of Linux containers. It's basically runc runs the containers from Docker. And basically it's like chroot and like seccomp maybe and namespaces and like a few things, right? And that hasn't like historically been like a super strong way of isolating code, especially since we're building a multi-tenant environment. We wanted something stronger. We ended up using gvisor instead. Gvisor is a product from Google. So I mean, there's limits to like how much we want to build ourselves. And even though we built our own scheduler and our own file system, like we think that gvisor is a super solid product. And gvisor basically is like somewhere in between a VM and a container runner. Like it basically like provides its own layer of like virtual memory, like intercepts all the syscalls, has its own very limited implementation, or like basically implements all the syscalls in terms of a much smaller number of syscalls, so you have a very low surface to the kernel. So there's a few different things like where we felt like gvisor is like, today strong enough isolation of code that we felt very comfortable with. I think in the future, like we want even like more like sort of isolation things. Like some larger customers, obviously, they're going to want to run things inside their own environment or have dedicated machines or whatever. And we'll look at that once we get there. But right now, I think gvisor is like a very strong isolation mechanism, and we're pretty happy with it.
Yeah, and maybe talking about, so you said you've built your own file system, you built your own scheduler, and I think maybe related to a couple of those things, I saw that you all recently put out kind of an architecture deep dive where you talk about how you translate incoming HTTP requests to function invocations and how that's a hard problem. Do you want to talk a little bit about that? Because I think, I imagine that is a thing that you've invested deeply in from a technical perspective over, or it looks like many months.
Yeah, I mean, I think like one of the things that have made things a little bit easier for Modal is we decided to take a like very integrated approach between the infrastructure and the SDK. And so we basically said in data, AI, machine learning, everyone uses Python. We're just going to focus on Python for now. Maybe in the future we'll add other languages, but let's do Python for now. And it turns out like specific for web requests, pretty much every single web framework in Python uses an underlying thing called ASCII or WSGI. I forget what it stands for, but it is a kind of like a lower level like protocol. And we realized like we could take advantage of that. Like we ended up like building a small Rust service that takes incoming web requests, serializes it to basically like ASCII over protobuf. And then we use that internally in our function call architecture to like basically create function calls with these ASCII payloads. And then we send it out to containers running web handlers. And then on the Python side, like basically just take the ASCII, take it out of the protobuf and just execute it. And that works pretty well. Like we got it working for WebSockets recently. We can have like very high request volume. Not everything in Modal is a web handler, by the way. Like most things are just like native Python functions calling other native Python functions. But you can take a function in Modal and turn it into web handler in basically just like changing one line of code. And so we do serve, I don't know, like several thousand web requests a second. And things are pretty happy with the end result. We wrote a blog post yesterday, like you mentioned, that we published on the blog.
Yeah, and I think that's interesting because it's an example of trying to go and I think successfully going pretty far to make the abstractions actually work between the local environment and the cloud environment. I think the kind of quote unquote lazier version of that is just kind of wrap the function in like a REST API, and then it might work for simple use cases, but it's not actually a function invocation, right? And so then I imagine you run into lots and lots of mental model problems between the two.
Yeah, and I think the sort of programming model that we wanted, like for non-web endpoint functions, is you just want it to feel like you're calling a function in Python, right? And but you want to make it work across container boundaries. So you want to have one function running on one image, calling another function running on a different image. Like maybe this one, the second one is running on a GPU. Who knows? But you want to be able to just pass data just like you normally would, and that works in Modal. Like because Python has built-in support for pickling and like serializing and deserializing. So that part works reasonably well for like most objects.
Awesome. Well, we've talked a lot about the economic story, the technical architecture. Let's go all the way back to product. What's the thing that's coming in Modal that you're most excited about over the next, let's say, 6 months here? Is it just scaling the existing workloads and use cases, or is there something in particular that you're just can't wait to launch?
Right now, a lot of it's scaling, frankly, which is a good problem to have, right? But we definitely feel like we've reached the end of life for like certain internal services. We have to rewrite a lot of stuff, like rewriting it like smaller, breaking things up, decomposing it, rewriting it in Rust in general. So there's going to be a lot of work going into that. I think in terms of like features, it's hard to say. Like there's a lot of like enterprise table stick stuff. I think one area that I've been very interested in recently is training. I think Modal so far has had the most use for inference. So we have a couple customers like Suno, for instance, like just AI generated music, and they run a few hundred up to a few thousand GPUs and at any point in time, and we handle all the music generation for them on GPUs through Modal. And so like those types of use cases have been where we've seen most success. More recently, we've seen success with LLM fine-tuning. So RAM, for instance, uses Modal for fine-tuning LLMs and a few other companies. I think training is like the next area that I'm very interested in. I think in particular distributed training. You can train models on Modal already, but you can use multi-GPU single node, but you can't do multi-node training.
Yeah.
So that would be like one area that I'm like quite interested in, like trying to figure out, could we make the ergonomics like really nice? If you're just like
Yeah.
training a model, could you like change a couple of lines and now you're training a modal instead?
Yeah. Yeah.
And it's distributed and you're using 100 GPUs, so you can train it 100 times faster
Yeah.
in like very bursty ways. And you don't have to think about like launching instances and running bash scripts to like just having the ability to take some code and just like parallelize it.
Yeah. Yeah.
That's an area that I'm very fascinated by. I think we can build some really cool products there.
Awesome. Well, that's really exciting, and I think it's particularly interesting that you get to take all of these new use cases that are unfolding in front of you and really think about how can we make it easier from a developer experience perspective, but ideally just unlock new things that otherwise would potentially not be feasible if you were having to build a lot of this infrastructure yourself. So
Totally.
excited about the future of Modal, and thanks again for chatting today. I really had a good time.
Yeah, thanks. Thanks for having us or having me. This was awesome. Really enjoyed it.
Awesome. Thanks, Erik.